right, Algebra 2, 1.1 notes. We're going to cover domain, range, and what is a function. So we're going to start with this idea of a relation. A relation in math refers to just the pairing of elements from two groups. We usually work with X and Y. So an ordered pair is an example of a relation because it pairs an X value and a Y value together. All right. The domain refers to the input or the X values, and the range refers to the output or the Y values. So notice that all the terms are alphabetical. That's the way I remember it, that X comes before Y, input I comes before output O, domain D comes before R for range. So there are many ways to represent relations. So you guys are probably super familiar with ordered pairs. They can also be in a table. You could go ahead and graph XY coordinates. You may not be as familiar with a mapping. A mapping just takes the X values right here, the X values and pairs them with the Y values and shows you that 4 is paired with 1, 6 is paired with 3, and 6 is also paired with 5. Different way of showing it. Or you could write it as a equation, y equals 5x plus 7, which you can just make a table of values that satisfy that equation. Okay. So this is just reiterating that the domain is always the set of the inputs, right? And range is always the set of the output. So let's take a look at a mapping here. Here's an example. Identify the domain and range from the mapping, okay, and list the coordinates contained in the diagram. So we have our X values, our domain, and our Y values, our range. Actually, I should do that in blue, right? So my domain is 2 and 5, and my range is the 3, 5, and the 6. If we write it as an ordered pair, 2 is paired with 3, but 5 is paired with both 5 and 6, you see there. Why don't you try this one on your own? This should look familiar. We got a graph there. So pause it and then check your answers against me. There you go. Check your work. List out the ordered pairs and then list out the domain, the X values, and the range, the Y values. I'm not going to read this whole page to you, but I'm going to point out that a function in math refers to a relation in which the elements from the domain, the X values, are paired with exactly one element from the range, the Y values. So in other words, each input X has one and only output Y. That makes a relation a function. The shortcut I like to use if you're looking at a table of values, each X is listed only once for it to be a function. If an X is listed twice, it is immediately not a function. All that information in your notes packet below this is just for you to take a look at. I'm not going to read it to you. We're going to take a look at these 4 examples and determine if they are functions or not. So the first one, I've already listed out the ordered pairs for you. Do you see an X value listed twice? So here's what I'm talking about. I have a 4, a 5, and a 6. Nothing's listed twice, so this is a function. Now, if we look at this next one, this will show you what's not a function. 4 is paired with 0, but 4 is also paired with 1. That immediately tells you this is not a function. Okay, because each X can only be paired with one Y. And right there, the X value of 4 is paired with both 0 and 1. That's bad. So if we take a look at this table of values, do you see any X value listed twice? I do not. So this is a function. If we take a look at the next one, do you see any X value listed twice? Oh, I got 3 paired with both 6 and 10. So that is not a function. So now let's take a look at a different representation of a relation. We're going to look at some graphs. So the vertical line test says when determining if a relation is a function, we look for any X to have more than one Y. Vertical lines are representations of X values on a graph. So draw any vertical line, and if it touches the graph, intersects a Y value more than once, it's not a function. So if we take a look at these graphs, let me get this out of here. This first one is a function. Okay, so that if I drew a red vertical line across that relation, it's never going to hit the graph at more than one spot. But if I take a look at this graph right here, let's say this X value right here is like X equals 5. Well, 5 is being paired with maybe -1, 5 is being paired with like 2, and 5 is being paired with like 6. That is bad. So visually, that looks like a vertical line is hitting that graph at more than one place at one time. So that is not a function. We call that the vertical line test. Now let's see if we can figure out the domain and range from a graph instead of looking at ordered pairs or like a table of values. So when looking at ordered pairs and mappings, it's super easy to see the domain and range and test for a function. But here, graphs are more difficult because they require you to really look at a section of values in the coordinate plane. What's the domain and range of this graph at right? So if we look at this blue graph here, the domain is going to be all the x values, right, along the x-axis. If we highlight the x-axis, right, this is the part of the x-axis where that graph exists. And then the range is the y values where the graph exists. So it's going to be all of these values. Okay, so how do we go about writing that? So if we want to write the domain, we need to know where it starts on the x-axis. It starts kind of at -3 here, and it goes and goes and goes all the way till we get to 1. Okay, now this right here is a really important point. That open circle means that the graph stops there, but does not include that value. I've written that down there. Now the closed circle, so if we look at the closed circle, so like right here, that closed circle, it does include that value. So this point here of 1, -4, it includes those values. But that other point that had the open circle, which was -3, 0, it goes to that point, but doesn't include those values. So if we wanted to list out domain and range, we have domain. The domain starts at -3. We include -3, and everything along that yellow highlighted area, we go from -3 to -2 to -1 to 0 all the way to 1. So that's the x values that are included, right? It includes 1, but does not include -3. So we do not write a line underneath the inequality symbol. So what that's saying is it's all the values of x that are greater than -3 and less than or equal to 1. Okay. Now the range, on the other hand, we're going to be looking at the y values. So everything there highlighted in green. So we start at 0 and it goes down to -4. And those are going to be my y values. Okay. Now, does it include 0? Well, it doesn't include 0 right here, but it does right here. It's only when there's an open circle at that specific point does it not include that value, but it does include it at the origin, okay? And then the lowest y value on the graph is -4. So we're gonna include those values. That was a little tricky. We're gonna go ahead and practice those on the next page. All right, example number 3. Identify the domain and range from the graph. Then determine if the relation is a function by applying the vertical line test. Before we get started, I want to reiterate these 3 things up at the top that I wrote. If the graph it ends or starts with an arrow, that means that the graph is going towards infinity in that direction. Okay? If the graph starts or ends with a filled in point, it does include that point. If the graph starts or ends with an open circle, it does not include that point. Okay, so that informs your inequality symbols. And we're also going to have to learn the infinity symbol, which is sort of a sideways 8, which is going to look like that. Okay, and we're going to be going towards positive infinity, or we're going towards negative infinity. We'll see those examples. Let's take a look at these first 3. So problem A here, if we're looking at domain, remember that's x. The graph starts here, right? We have an open circle, and there's graph, 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 and then it stops here. So those are our boundary values. So this first boundary value here is at -5, and then it ends at that boundary value of 6. And notice it doesn't include that point, but it does include that point. So we start at -5, we go to 6, write our inequalities. It does not include -5, so we don't underline the first inequality symbol. It does include 6. So there's your domain. Range are our y values. So we're starting at this value here. We're going down, 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 and it stops there. So our boundary values, we've got -7 here, and it goes up, 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 up until we get to 1. It does not include that, and it does include this, but that doesn't matter. It does include 1. Okay, so my range starts at -7. Range are y values, and it goes up to 1. It does not include -7, but it does include 1. So if it's not an open circle, you assume that it includes that value. So is it a function? Well, if I started drawing vertical lines, it's never going to cross that graph at more than one place at one time. So yes, it is a function. Now, problem B, we have arrows, right? We have arrows. So we're going off to infinity and beyond, like they used to say in Toy Story. So my domain, it's going on. And since that arrow is going, we're going to infinity. And since the arrow is going on and on to the right, we're going to infinity. So that's going to look like this. My x values, we're going to -infinity to the left. We're going to +infinity to the right. And we don't write the underline symbols because infinity isn't like an actual number that we can specify. So it's never going to equal some number called infinity. It's just the concept of infinity. Okay. Now, if we look at range, this arrow is going up forever. So we're going up, 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 up forever. This arrow is going down forever. And it's going to go down, down, down forever. So again, we're going to start at -infinity. Okay, it's the y values. And we're going up to +infinity. Here, my infinities have never been good. Okay. Now, if we try the vertical line test, we're never going to cross that graph at more than one place at one time. So yes, it is a function. Okay. This one's a little tricky. This arrow, that's going to infinity. If we're looking at the x values, it's going to infinity. It keeps going to the negative, right? And my y values, oh, they stop right here. So there's a boundary value of 6, right? So my domain, -infinity, and we're going to 6, and we are including that value. So the domain looks like that. Range, we're looking at the y values. So it starts here, doesn't go any bit above 3, and it goes down, 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 down. It looks like it stops there. However, this arrow is going to go down forever to infinity. Okay, so I have a boundary value up here of 3, but it goes down to -infinity. So the values start at -infinity, and we are going to go up to 3, and it includes that value. Okay, take a look at these. Why don't you try these next ones on your own, and I will write the answers. Okay, here are our answers. You can take a look. D here, your domain is going to -infinity and +infinity. Range, the value never goes below -6, but it goes up to infinity. Is it a function? Yes, passes vertical line test. Now, E is interesting. It is not a function. It fails the vertical line test. Notice that the green vertical lines hit the graph at 2 spots for every x value, right? If x is 1, there is a y value of 5, and there's a y value of -3, right? So that by definition is not a function. Domain and range is pretty self-explanatory. And F is a vertical line. So for every x value of 4, it's paired with a whole bunch of y values. So that's not a function, okay? The domain is only x, and the range obviously goes from -7 to 4. Good luck.